Good morning, everyone. Our group will be presenting the artificial intelligence and big data analysis in forensic science. And our group members are Abhitra, Shantini, and Vishnu. So next is the introduction about the artificial intelligence, also known as AI. It's defined as a field of computer science and engineering concerned with information processing technologies that integrate models and algorithms which produce a capacity to learn and to perform cognitive tasks, leading to outcomes such as prediction and decision making in material and virtual environments. However, AI improves human experts' performance in the field of forensic sciences by removing the constraints of subjective bias. This method is labor-intensive and time-consuming since it depends on forensic specialists to gather data and offer their opinions by hand. By using the AI tools in the forensic science, new information can be gathered from enormous data sets to improve knowledge, lessen human subjectivity and error, and finally provide expert testimony and provide a stronger foundation that may support its admissibility. So what's forensic genetics? Forensic genetics is a subfield of forensic science which involves the application of genetic analysis in criminal investigation. It focuses on the examination of DNA and other genetic material to identify individuals and establish biological relationships. So far, there are some well-known technologies that involve in forensic techniques, which are the polymerase chain reaction PCR, real-time PCR or PCR, short tandem repeat analysis (STR), and single nucleotide polymorphism, and last but not least, the next generation sequencing. So, what is STR mix? STR mix is short for short tandem repeat mixture analysis. It was developed by the Institute of Environmental Science and Research in New Zealand and the Forensic Science South Australia. The software uses advanced combinational methods to analyze DNA profiles from a mixture of 2 or more individuals, which are often encountered in forensic casework. Now, the importance of STR mix is the crime scenes often yield data samples that are each mixtures of genetic material from multiple individuals, and STR mix is designed to handle these complex mixtures, providing clarity where traditional methods might fail. It can accurately identify and separate the contributions of multiple individuals even when their DNA is present in unequal amounts. Besides that, by using advanced statistical models, STR mix can account for uncertainties and variabilities in DNA data, leading to more precise interpretations. It effectively handles issues like ELI drop-out and drop-in, which are common in low-tempered DNA samples, thereby reducing the risk of misinterpretation. Moreover, STR mix calculates likelihood ratios, which provide a robust statistical basis for determining the probability that a specific individual contributed to the DNA sample. The use of the Bayesian framework allows for the incorporation of prior information and provides a comprehensive probability-based analysis. However, STR mix is widely accepted in courts around the world due to its rigorous validation and the transparency of its methodologies. Its probabilistic approach is increasingly recognized as a gold standard in forensic DNA interpretation. So, automating the complex calculations involved in DNA mixture analysis reduces the time required for forensic scientists to interpret results, allowing them to allow more cases efficiently. Last but not least, it aids in solving complex cases involving multiple suspects or victims by providing clear and accurate DNA analysis. STR mix can reanalyze old or degraded DNA samples, potentially providing new leads in unsolved cases. The software is also available in civil cases such as determining familial relationships or resolving inheritance disputes. The principles of STR mix are the first DNA profiles generated from the samples, which is obtained from the crime scene, and the STR mix software will be installed on the computer, and the DNA profiles will be imported into it. Then the electoral program is loaded into the software. Secondly, analysts will configure the model based on the initial assessment of the data, specify the number of contributors to the mixtures, and this is a critical step as it influences the subsequent analysis. Third is the STR mix performs a detailed statistical analysis, deconvoluting the data mixture and calculating the input ratios. Also, STR mix will use its probabilistic models to separate the mixed DNA profiles into individual contributor profiles. Fourth is the software will generate a comprehensive report, including the likelihood ratios. For example, it will provide like the suspect is a contributor, vs the suspect is not a contributor. And finally, a detailed breakdown of the statistical analysis. And finally, the last step is the forensic scientists review the results and prepare to present their findings in court, where they needed to explain the probabilistic methods used by the STR mix.
Hello everyone, I'm Parutramani. My metric number is SP22098. Today I'm going to share the advantages of big data. In the field of forensic sciences, AI application could contribute to enhancing human experts' performance, overcoming the subjective bias limitation of traditional approach of the forensic sciences. Traditional approach required time and efforts, relying on forensic aspects to manually extract information and provide opinions based on medicine, biology, and other specialized field of knowledge. Second, applying AI tools to collect new information from massive data sets. It is to enhance knowledge, reduce human subjectivity, and providing greater scientific basis that could favor the admissibility of expert evidence. Third, greater scientific basis. By internalizing data in ways not completely audited or understood by humans, AI technologies can provide greater scientific basis for forensics analysis, potentially improving the admissibility of expert evidence. While big data offers numerous advantages in forensic sciences, there are also several limitations and challenges associated with its use. First, data quality and quantity. AI algorithms require large amount of high-quality data to train effectively. In forensic sciences, obtaining such data sets can be challenging due to the limited availability of standardized and comprehensive forensic data. Second, complexity of forensic data interpretation. The interpretation of forensic data, such as genetic markers for DNA typing, can be complex and error-prone when performed manually. AI tools must be carefully designed and validated to ensure accurate interpretation of forensic data. Last but not least, high cost and results requirement. Infrastructure investment is crucial to setting up and maintaining big data infrastructure, requires substantial financial investment in hardware, software, and skilled personnel. The operational costs are also high for data storage, processing, and management. That's all from me. Thank you.
Greetings, Doctor, and also my fellow friends. My name is Shantini, and my matrix ID number is SP21081. Today, I'm going to talk about the patterns and social consideration that may arise by using AI and big data in the forensic field. Firstly is privacy concerns. AI and big data analysis often involve processing large amounts of personal data. There's a need to ensure that privacy rights are respected and the data is handled securely to prevent misuse or unauthorized access. Besides that is transparency and accountability. Patent AI algorithms used in forensic analysis should be transparent, with clear documentation of how they reach conclusion or make prediction. Additionally, there should be mechanism in place for accountability if error occurs, including avenues for challenging and correcting erroneous findings. Then is accessibility and affordability. Patents should not create barriers to access for forensic technologies. There should be efforts to ensure that AI powered forensic tools are accessible to all law enforcement agencies, regardless of their financial resources, to promote fairness and effectiveness in criminal investigations. Now I'm going to talk about the ethical consideration that may raise by using AI and big data. Firstly, bias and fairness. AI systems can inherit biases from their training data, which may result in unfair or discriminatory outcomes. AI algorithms can unintentionally perpetuate or even exacerbate existing biases present in the data, which can lead to unfair outcomes. Besides that is data protection. AI often relies on large data sets, raising concern about the data privacy. Ethical AI practices involving the protecting individuals' data and ensuring transparency about how the data is collected, used, and stored. These ensure that the data used is accurate, complete, and up to date is critical to avoid erroneous conclusions. Then, anatomy and control. Ethical AI considers to the degree of anatomy given to AI system and the control mechanism in place. This will maintaining the human oversight and control is important in critical decision-making processes. Maintaining human oversight is essential to ensure that AI-driven decisions in forensic anatomy are reviewed by qualified professionals who can apply ethical and contextual judgment.